All right, so we're going to talk about one more thing for random numbers, and this is totally optional. If you're not interested, feel free to skip this. But we are going to talk about something very different than Ken Perlin's super visual Perlin noise, and instead talk about cryptographically secure random numbers in JavaScript. Now, if you're interested in cryptography, you've probably read about this kind of stuff already, and I'm certainly no expert, but I think this is really interesting, and it's a very different way of making random numbers in JavaScript. So let's take a look. So the first thing is, we could read the Wikipedia article or a book about generating cryptographically secure random numbers, but this is a whole field of study. It's better to let other people do that work generally. And so I just went to the Mozilla web docs and looked up cryptographic random number. And sure enough, here is a whole article about it with examples and stuff. And I think this is a really good idea. If you have any topic in JavaScript that you don't know about or are curious about, it's such a widely used language. There's tons and tons of examples. And actually, I'm getting ahead of myself. So what is a cryptographically secure random number? Well, when we think about things that we do online, where we want privacy and security, random numbers are actually really, really important. So when I transmit my credit card number or place an order online or password or anything like that, these random numbers are really important for how they're storing and keeping secure my data online. And so we can think of cryptographically secure random numbers as being very, very random. So you can actually measure randomness. The linear congruential generator we use is very unrandom in this sense, but the generators used here are really, really random, or demonstrably much more random, I guess is a better way to put that. How that's generated is gonna depend on what kind of computer you're using. But a really common source is actually entropy or noise from your hard drive on your computer, which makes me really happy. So we're going to look at how we can generate those numbers. The result is not going to be that different than what we see from the built-in random function, but I still think it's kind of interesting. So I'm just going to add no loop here. So if I want to generate a random number using this cryptographic system, it's going to require some extra steps. So I'm going to go ahead and make a function for this. So I'm going to say function, and I'm going to call it crypto-random because otherwise it's going to get too long. And I'd like this to work basically the same way that the built-in random number generator works. So I want to be able to pass in a min value and a max value and have it send back to me this random number. Now, P5JS, one of the awesome things it does is it actually hides a lot of the messy bits from us to make it much easier to start writing code and make drawings and stuff. But as soon as we stray from kind of the tidiness of P5JS, it starts to get a little messier. So let me walk you through kind of how this works. Like I said, by no means an expert in this, but so I want to create a value and a random value. And to do this using the crypto code for JavaScript, the crypto library, I have to do it a little different than I'm used to. So the first thing I have to do is create an array. Because this algorithm is going to want to create an array of random numbers rather than a single one. Not sure why. Maybe some of you are smarter than me and you know all about this. You can share it in the comments. But I have to create this blank array that then we can fill with random numbers. Now, aside from that, we also have to specify exactly what kind of number we want it to create. So before we had talked about floats and ints, floating point and integer numbers, but actually if you go a layer sort of deeper, you can specify even more specifically what kind of numbers you want. And in this case, we're going to ask for a 32-bit integer. So this line here creates a variable called value, and that value is a blank array, so nothing in it. In this case, it only has one number or one slot in it. There's no numbers in it yet. And those numbers are all going to be 32-bit integers. And if you're like, whoa, my head is spinning, I don't know what any of that means, don't sweat it. We don't need to worry about that. This code will just work. Okay, so then the next thing we need to do is fill this array with random numbers. And so we say window.crypto.get random values. And value then is where it's going to stick that those random numbers. So I've got a blank array. I fill that array with random numbers. In this case, it's just 1. But we want then to get this into the range of numbers that we were looking for. And for this, we can use processing's really awesome map function. And this takes an input and an input low and high range, and then an out low and out high. And we're going to use this a lot in future examples. So file away map in your brain. And so value, then I'm going to say map is equal to map of value 0, the first element in that array and our only element. Now, how do we know what the input high and input low are? Well, there's a number of ways that we could do that, but a 32-bit number equals 2 to the 32nd power, which happens to, if we do this on our calculator, happens to equal 4,294,967. 4,294,967,296. Now, our number can either be positive or negative, which means half of that range is going to be on the positive side, half on the negative side. So actually, our numbers are going to be, and I'm going to copy paste this so I don't do it wrong. Boom, negative half of that. And then our output range is going to be min value, max value, like that. So now we know we're going to get a number between these two numbers that's also cryptographically secure. Pretty cool. When we're done, then we just say return value. So let's run through this one more time, and then we'll see it in action. Our function takes in a minimum and a maximum output value. We create a blank array of 32-bit integers, and this array has nothing in it and only one little slot. Then we fill that slot with a random number from this crypto library in JavaScript. Then we convert that from its initial range, which is these big crazy numbers, into the range we asked for, and then we send it back to our program. Okay, so let's verify this is working, and then we can go ahead and try to use this. Like I said, we're not actually going to see that much of a difference, but it's still pretty fun. So we're going to say let random number equal crypto random between 0 and 1,000. And then we can view the results. We run this and we get 955, 805, 833. So we should always see numbers between 0 and 1,000. Like I said, they're random. They don't look that different to us, but these are generated in a very, very different way than is done using just the built-in random function. So I'm sure if you're like me, you're dying to see how random they look. So let's go ahead and do that. I'm going to do a for loop. Let's do fill of 0, no stroke. And we'll just do a quick little for loop and draw some circles. So let x equal crypto random between 0 and width. Oops. Between 0 and height. And let's also do diameter. So crypto, just copy this. I don't know why, I have a very hard time typing crypto random. And then we can just do a circle at x, y, and diameter. Oops, I'm missing my ending curly bracket. Awesome. Okay, so there we go. That's random circles of random sizes using JavaScript's cryptographic random number generator. I don't know, if you're still here, you're really awesome. I'm a super nerd for this stuff. Maybe this isn't that interesting to you. And of course, there's lots of other ways of generating random numbers in the computer, and you might check some of those out. But for now, yeah, we're going to leave it there and talk about your assignment.